Alright, we're going over triangles. Okay, so types of triangles. Scalene triangle, isosceles triangle, equilateral triangle, and then those are called classification by side length, and then you have classification by angle measures, which is acute, obtuse, and a right triangle. Okay, let's get it. All right, so types of triangles. So scalene, isosceles, equilateral. Okay. Types of triangles, this is how you spell it. Okay? Pause the video, spell it. Write it in your notes. Okay? Equilateral. That basically is a triangle. I went out of order, so what? Equilateral triangle, that basically is equal sides as well as equal angles, and it will be labeled as such. Okay? Equal sides, equal angles, equilateral. Okay. In a triangle, all triangles add up to 180 degrees. Therefore, because there are three sides or vertices in a triangle, you divide 180 by 3, and equilateral triangles have each angle is 60 degrees. Okay. Isosceles. It looks like this typically. Isosceles triangle typically looks like that one right here. That means the base angles are congruent, they equal each other, and the left and right leg, base, whatever you want to call it, side, there we go, left and right side are congruent as well. Okay, and the reason that is because if you have an angle here, it opens up to a certain degree, and therefore it goes to this side and it goes to that side, and it does the exact same thing. So if the base, basically like this, if you plant an apple tree seed, you expect an apple tree. If you plant an apple tree seed, you expect an apple tree. I said the same thing twice. That's basically what this is. You planted an apple tree seed, and it grew up to be a side, and that is the apple tree, and it's about going to be the exact same type of tree as if you open this side, this seed grows up, tree, blah blah blah, same side. Okay, cool. If you didn't like the analogy, sorry. Orange tree. All right. Scalene. Basically, this means all the sides are different lengths. Okay. So basically, it'll look like this. It'll look like this, okay? I mean, this is a side, this is a side, this side, they don't equal each other. This is a side, this is a side, this side, they don't equal each other, okay? I'm sorry, angle. The second set are angles. Angle, angle, angle. Side, 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 okay? So, that's what scalene, isosceles, and equilateral triangles are. Now, classification by angle. An acute triangle. Looks like this. Okay. Okay. I drew all of them, but yeah. Okay. So, an acute triangle. That means all the angles are acute. That means they're less than 90 degrees. They're not necessarily, it looks like this, but it's not necessarily an equilateral triangle, but okay, let's say it this way. An acute triangle is not an equilateral triangle, but an equilateral triangle is an acute triangle, okay? Okay, if you didn't understand that, rewind the video back, listen to it again until it makes sense, okay? Obtuse. That is a triangle that has at least one obtuse angle in it. That typically describes, guess what, a scalene triangle. And then we have a right triangle that isn't described by any of these ones. A right triangle has a right angle in it, and when you go up to higher levels of math, this is pretty much the main triangle you'll be working with. So have fun getting to know your right triangle here. Okay. So right triangle, right angle, 90 degrees. You know that. That's a distinguishing factor in it, as well as equilateral. So equilateral, we know it's 60 degrees because 180 divided by 3. Cool. And we know that this right angle here is 90 degrees. Therefore, that's just angle that you need to know. Okay. All right, done with that part. Triangles are congruent when they are the same shape and size. That is when corresponding angles are and sides are all congruent. Okay, so basically what this is saying is, I probably won't explain it correctly, but I'm going to draw it for you, make it look better. Okay. Okay. So this is when you start getting into congruency and similarity. So let me show you what that looks like. Okay. A, B, C, D, E, F. Okay. Clearly this triangle is bigger than this one, right? Okay. So basically, let's say it's like this, right? Let's say side AB is 15. This is 12, and this is 36. Therefore, this side is 12, this side is 4, this side is 5. Okay. 12, 15, 36, 5, 4, 12. Okay. So basically what this is saying is these triangles are similar, but they're not congruent. Okay. And the way to label a similar triangle is triangle ABC. You start off like this. Triangle ABC. Squiggly line, remember that? Squiggly line. Triangle DEF. Triangle ABC is similar to triangle DEF. Okay? Cool beans. And this is also basically saying, right, the triangle ABC is going to mean that measure A is equal to measure D. Oh, okay, cool. This is also saying that if you have this, how about this? If you have something like every kitchen has food in it, and then you say your kitchen has food in it, my kitchen has food in it. You see how you had that all declaring statement at the beginning that was all kitchens have food, and then you basically gave an example. Your kitchen has food, my kitchen has food, their kitchen has food, his kitchen has food. Basically, we're just restating what that said. Okay, so all colors are pretty. Green is pretty, blue is pretty, pink is pretty, red is pretty, all that type of stuff. Basically, you have that overlying statement of all colors are pretty. So this is your overlying statement of triangle ABC is similar to triangle DEF. Therefore, you can break into that and say measure of angle A is equal to measure of angle D. That's a stretch, but make it work. Measure of angle B is equal to measure of angle E. Measure of angle C is equal to measure of angle F. It's not really a stretch, actually. All you're saying is, since these are similar triangles, that means this angle is exactly that angle, and this angle is exactly this angle, and this angle is exactly that angle. That's all it's saying. So, yeah. And also, there's this also statement. Let me write it real quick. Okay. You know how when you have... Oh, that feels good. Okay. You know how you have... Okay, maybe not that example. So you have AB over... Where is it? DE? Yeah, there we go. AB, DE, right? 12, okay, so basically what the property is saying is the side, so if you have AB and DE, if you divide one by another, you will get the same thing if you divide any other side by the other side, or its corresponding side to be exact. So specifically, where is it at? There we go. AB divided by DE is the exact same as BC divided by EF and AC divided by DF. You will get the exact same thing, and that number that you get, whether you put the smaller number on the top and the bigger number on the bottom, or the bigger number on the top and the small number on the bottom, that is called your scale factor. Okay? That's called your scale factor. Alright, that is the end of part 1. You can get ready for part 2.